This video will demonstrate SEL's Synchrowave Central software as applied to the NASPI 2014 Oscillation Test Case number 2. Modal analysis is run on the first derivative of generator power, normalized by its ambient standard deviation. The signal is also passed to the alarms processor. The alert and alarm thresholds are set to 6 and 10 standard deviations respectively. The modal analysis technique employed here is total least squares. This one-line diagram shows the test system for oscillation test case number 2. The locations of generators 1, 6, 7, and buses 2 and 4 are displayed in the Synchrowave Central map as shown in this animation. Here is an overview of a standard pre-configured display. The upper left shows a sample representative system of this model. The upper right shows the scaled input signals to the modal analysis displayed on the alarm threshold plot, and the bottom shows the generator powers on their own plot. Now we'll transition to the modal analysis detailed analysis display. The bottom left shows the generator 1 input signal along with the modal analysis frequencies. Top left shows a plot of the frequency versus damping ratio for each point shown below. Upper right is frequency versus amplitude. Bottom right is damping ratio versus amplitude. Back at our overview display, you can see a spurious alert on generator 1. I'll click the alert notification to display additional information. Here you can see the alert and then alarm notification have activated. Switching to the detailed modal analysis display, we can see several red dots on the amplitude versus damping ratio plot. If I scroll this over to the right, you can see the dots develop as the oscillation grows. Now I click on the clock, turning it green and returning us to real-time mode. Here we've switched to another view showing the alarm thresholds and the modal analysis simplified display. We can see the blue curve here representing generator 1 has a growing oscillation. As it passes the yellow and then later the red, the alert and the alarm thresholds are passed, triggering the alarm annunciator. Now we can show additional information by clicking on the annunciator, where we can either clear it or jump to the event. Back on our overview display and switching to real time, you can see again the blue is much larger than the other two generators, indicating that the most likely source for the forced oscillation is generator 1. As we reach the end of our test case, you can see the oscillations decreasing in magnitude on the right-hand plots, and in the lower left-hand plot you can see the magnitude of the sinusoid decreasing.